For those of you who are expecting Lee Kelleher, you've noticed I'm not him. I'm disappointed too. But today we're going to talk about load testing, and we're going to use JMeter. And I've got good news for you. This is not an AI talk. Yeah. So I'm going to get on a soapbox for a little bit here because, ladies and gentlemen, we are all craftsmen, right? We have honed our skill over many years. We have built our businesses on providing amazing code, amazing experiences for our clients. And these AI tools, frankly, some of the stuff these machines are turning out is like laughable and weird. You know, we don't need to work these things into our workflow. Our clients are not just gonna up and leave because this stuff is a little faster, a little more convenient. We can keep doing things the way we've always done them and just keep running our business like we always have, right? Well, the reality is that right now, we're probably in the biggest state of change that any of us have had in our careers. What the Industrial Revolution did for manufacturing in the late 1800s, AI is doing now for knowledge and expertise. And so we really have two options. We can either ignore that and go the way of the saddle makers, or we can adapt that and get on the bus and start using it. So I just want to start this out by encouraging that. I promise I won't say AI again, but throughout this talk, there are some prompts at the bottom to say, here are some ways that if you haven't started playing with this stuff, some ways you can get going on it. So, okay, that's it. Let's talk load testing. So here's the situation. Your team has spent months building amazing new software, amazing features into your website. The marketing team has gone all out, spent their entire budget to really get people to come and show up and see the amazing new experience you're offering. It's the day of the launch. And success. You have a bunch of new people that have shown up and they're hitting your website, they're going through it, they're seeing all these great things you've built. Wow, there's a lot of them. Fantastic. Oh no, there's really a lot of them. Maybe we better check the server. That can't be good. So as people pile up, they're all coming and getting stuck at the front door of the website, and those requests start queuing, right? Because as the server can't get things done fast enough, more requests queue up. What do you do when the website doesn't load? You hit F5, you try another browser, and now the same people are in line 2 and 3 times. The launch is falling apart, and the big day is ruined. Your client fires you, your partner leaves you, your dog runs away, and the only recourse you have left is to write a country music song. Ladies and gentlemen, we do not need, as a culture, another country music song. So how can we avoid this? We're gonna test to make sure things work before we get started. And we're gonna do that with load testing. So briefly, high level today, we don't have a lot of time, but we're gonna talk through how to plan a test, how to execute, how to analyze those results, and at a high level, some broad ideas of how we might improve those things going forward. So first off, you know, back in the old days, it used to be, well, if you wanted to plan a load test, just throw a lot of traffic in the website until it breaks, and then you're good, and then you know how much traffic you can handle. But the reality of that today, with things like scalable servers, Cloudflare, edge caching, you probably can't really totally break the thing, so you have to do a little more planning. So first off, let's think about how we should choose a target size for our test. And personally, I like to boil this down to a simple number. How many requests can we handle in a second? So there's a couple ways you can go about finding that. Ideally, you could go to your marketing team and say, like, how many people do you think will show up? And let's pick some multiple of that for safety and go about using those numbers. I could look at, you know, what do they think their reach is? If they've got good metrics, great. You know, what's their response rate? If they have a big mailing list, they know what the click rate is, and they're gonna send a email out that has, you know, the call to action, they can probably make a little response curve of like, okay, well, we know this many people open based on the past time within a certain time, so we can kind of plan that load. I've certainly talked to a lot of marketing departments that don't have this data. Okay, well, let's look at our analytics. Let's boil the analytics down to what was our busiest day ever. Within that, what was our busiest hour ever? And take some multiple of that. Is it gonna be 10 times, 100 times our busiest time ever? And then Beyond that, we can even look at some comparables for other high traffic sites. And because I've found when I'm talking to the C-level executives that are paying for this stuff, well, we can handle 200 requests per second. That doesn't tell them anything. I get questions like, well, is that like Facebook? Is that like Google? You know, and it's like we have to say, well, unfortunately, those guys don't give me any numbers. But you can do some very bad back-of-the-napkin math. So I put a sheet together because actually Wikipedia, they do give you numbers. So their visitors are known, and they actually have a page that they'll tell you how many requests per second they're handling. And so if you do some very bad and sketchy math, you can kind of, drive this out for your other things as well. I would never use these numbers to actually calculate, but just to give somebody an idea of scale. Like you can be an order of magnitude off, but it just gives you something to compare against. So now that we know how big we're going for, we've picked some number. In the case of the test we did that little example for, they said like, give us our busiest day times 1,000. So that was something like, 20,000 requests per second. So what should we look at for things we can test for load? Well, really anything that we think can cause heavy load. If we've written a bunch of new code, and maybe that's, doing a bunch of calculation, let's make sure that's in the test. If we have any external dependencies where we're relying on some database, somebody else's API, anything that gets called every page, or maybe the cache clears enough that we know we better handle it, let's include that. 404s are a surprising source of load, because if you think about it, the 404 page pops up when the controller runs, the router runs, goes through the website and goes to the CMS, looks for everything, and then doesn't find anything. So it has to first say, well, is there anything here? The answer is no, and so it returns the 404, and sometimes, like you say, okay, well, if it's not in the CMS, it's in the product database, and so there's extra code there. And then typically you don't cache that, because it's not a 200 response, it's a 404, and somebody might write that page later. So 404s tend to be something that we want to make sure are at least considered. Any type of page that does personalization or anything with a query string, particularly like if you have somebody sending out newsletters, and those include like campaign codes where the email is marked with a unique identifier. That's going to be a problem if that's not there, because those won't be cached. They'll skip around the cache, and those create load every time. And then we should also definitely look at the critical path. So if we're launching some big new feature or we're launching some new product, we should definitely test the buying journey all the way through that. And so for a broad test, what I like to look at is essentially, let's create some personas that go through journeys on the website and create some representative load. So we'll start with a broad test to test everything, see, hey, can we just handle a normal set of traffic, and then multiply that and multiply it until we get some load testing results. And then after that, when we figure out what's slowing us down, we can zero in on it with subsequent tests. And so what I like to do is then have a set of journeys that are tied to personas. And if I already have user strategy personas or marketing personas, I can already use those and say, okay, these are what my users are going to do. So at Blend for demos and testing, we have a site that we're going to do some persona for today. We've got the American Cat and Dog Association, which is an association of cats and dogs. And so we've got a couple of personas we'll include in our little sample test here. So the first is Hank. He's a golden retriever. He's going to be our kind of like happy path user. We're wanting to get him into membership, so he's going to go to the home page, read a couple articles, check the about page, do a search for membership, and then sign up. And then, to get that 404 and some of those other things, let's include a Klutz user as well. Hank's going to be about 85% of our traffic. And then we're going to have Ed. Ed is a tabby cat. He is representing a temporary impairment. He's drunk on catnip, which is something they didn't talk about, accessibility things, but here we go. So he's going to start by mistyping a URL he remembers. He's going to search for the word tuna, read the first article, realize he has a problem, and search for catnip addiction. So we've got a couple personas. He's going to be kind of our weird user, represent about 15% of the traffic. Okay, so now we have our personas, and the tool we're going to be using is JMeter. So what is JMeter? Well, it is basically like a Swiss Army knife for doing a lot of requests at scale. It's a Java program. It tests HTTP, HTTPS, FTP, like most web protocols. You can test Java code with it. And there are tools in it that we'll look at for scaling and analysis and those sorts of things. Some alternatives, K6 is a little newer. You tend to write code to write your tests. Apache Bench is where if JMeter is a scalpel, Apache Bench is a hammer. You give it one URL and you tell it how much you want to hit it, and you just hit it really hard. The paid version of, there's a paid version of JMeter called BlazeMeter, and really what it is a service that you can write your test plan and not have to have your own testing grid. You can just upload it and pay them to do it as well. And so here's JMeter. And I think it's pretty obvious from when it loads up what you should do first, right? I mean, well, let's click that icon there. Huh. So this is a software that is written for engineers by engineers. There's not a lot of user-friendliness involved. But basically, as we go through this, we'll talk through kind of some of the key pieces. So basically, the plan on the left side is going to be a tree. That's your testing tree. And then you've got your details on the right. So let's talk through what are the different parts of these tests. So at the core of it is something that they call a sampler. And all a sampler is for our purposes, one HTTP, HTTPS request. We're going to go do something. We're going to send a request to a server. We're going to measure how long that takes to get back and whether or not it was successful. Now those tests, those samples get grouped into a controller. And basically that controller is just deciding, okay, how do these samples run? The most basic ones, just run them in order. So go down the list, run all these samples. Or I can run them randomly. I can have them run based on certain conditions. But that's kind of how we group those things together. And those sort of become our user journey. Above that, then we have a thread group. So for each of these user journeys, how often is it going to run? What schedule is it going to run on? And then within that sample, we can also make assertions. So maybe we want to know that the page said a certain thing when it loaded to consider it a success. Maybe we wanted to know that it was had a certain header on it, or that we run code to check the page. So that assertion gives us a way to do that. We have a config element, which we'll look at in a little bit, but that allows us to add some configuration so we can use this test in various environments. And finally, we have listeners. And essentially what a listener is it gets all the metrics from this and groups them up so that we can look at them in some aggregate way, because when I run 20,000 samples, I can't look at them all, so I need to look at the statistics. So let's make a basic test. So thinking back to that tree we had up there, we're going to add a thread group. We're going to add, for this first one, something called a recording controller. What a recording controller does is you add it to your test, and it will start up a little proxy server that then you can point a browser at, step through the website, and that will record all of those steps as samples. So that's a nice way to start if I'm going to build journeys for these persona. And then I can tweak that, add configuration, and then add my statistics listeners. So first off, a thread group. We're creating a really simple one. And you can see basically the main thing on here is, okay, how many threads do I have? I can also say a ramp-up period. So if I want to say I have 100 users, maybe it takes a minute to go to from 0 to 100. And I can determine for each of my journeys in my controller, how often do they loop? So that way I can extend the test to try to get better data. This is the most basic one. Once you get up to testing larger scales, you can use something like the ultimate thread group or the stepping thread group. And what these do is let you set a more defined set of loads on a schedule. And a lot of times when we're testing this at scale, we're doing kind of the stair-step pattern. Reason being, if you're hosting on something like Azure, there's probably a rule in your Azure server that says something like, hey, if the load on this server is larger than 80% for 2 minutes, start up another server. So we want to see that scaling is going to work over time. And you can create a linear scale, but this is a little easier to create, works just as well, and it gives you some testing points. So here's our recording controller, and it's got companion item called the test script recorder. What this does is sets up where is my proxy server going to be. So I'm going to go into, I used Firefox in this case because I didn't want to mess up my normal browser, configure that proxy, and then here's the SSL domain we have to test. Because if you think about testing through SSL, if you put this proxy server in the middle, you have to issue a certificate so that the proxy server can actually see the traffic, and so we're going to do that. And then we also want to filter the test. So our website has things on it like Typekit, like Google Analytics. They really don't want to be part of our test. That's called a denial of service attack. So we just want to make sure that we are reaching just the audience that, or just the target we want to reach. And so in my case, I included our domain in here since our site was under that. So when we record this test, it's only going to include that domain. And here we go. If we let this run, so I go ahead and start it up. I get a little warning here saying, hey, you have to add the CA cert to your browser. Fortunately, I've already done that. And then for use later, I can name this set of recordings so that it'll show up in my test. And now I can just browse the website. So as we browse, we can see under that controller on the left-hand side, it's slowly building out our journey. Now you can certainly go in and add all these samples by hand, but this saves a lot of time, and it also gets things you hadn't thought of, like this site has Engage on it, so there's a lot of Engage pings in there that'll be on the real site. So it's a good way to make sure you capture all those things. So now that we have that, we can go through and enhance those with some assertions. So in this case, I've taken one of these samples and added this assertion under it that I want it to have a certain header, and I want the CF cache status to be either hit or miss. And so what that's going to tell me is, did Cloudflare cache this page, or at least try to cache this page? Because the other alternative for that particular header is if it says dynamic, that means Cloudflare has basically said, I'll never cache this page because I think it changes too much. So this tells me that our site is sending the right headers, the right expiration dates, so that we know it's cached, which in a load situation is really important. So beyond that, we've got some config elements we can add. There are some that are these managers that basically essentially add more browser behavior to this simple request modeling. So if I wanted to simulate that the browser has a cache, or maybe I want to insert a cookie, for example, like if there was a session that I wanted the test to be pre-logged in, I could put that token in there. Or if I'm testing an API, maybe there's some bearer token header that I can add. Request defaults basically will set it up so that I can override certain parameters of the request. So in this case, maybe I recorded the test on production, but I want to see if it works first, so I'm going to test it on QA, so I can swap out that server name. And this makes that test more reusable because I can try it on different environments, record it on one, use it on the other, etc. Now that that's all set up, that's great. Now I need some way to understand how I'm going to gather up my results. As we'll see as we look at the actual recording here, there's also a way to make it spit out a very nice HTML file with a bunch of results in it, but I can also aggregate things. The one thing I tend to always include is this generate summary results. That is a really basic listener, but basically every few seconds as the test is running, it's going to spit out some basic metrics to the command line that I started the test on. When you're running this on a server, like it's taking a lot of memory, a lot of RAM, sometimes it crashes. This number one makes sure at least I get a partial result, and I can also see that things are working well. So one of the things I'm always looking at as the test is running is like, how many errors are we getting? Like a lot of times, maybe you left a WAF on, and now all of a sudden your load test is seen as an attack, and you'll see those errors jump to 100. So it's just a way as the test is running to kind of get some idea what's going on, as well as if I have a test fail for some reason, I still get partial results that I can do something with. The other two that are listed here, and there are a lot of listeners, but just kind of listing some that are helpful, is the results tree. Now, this is not something you want to use on a production scale test because it just has too much stuff in it, but this will list out every sample, the request that was sent with it, the response that came back, and whether the test considered it a success or not. So you can see in this case, some of these guys have triggered where the cached assertion that I added has failed, which means that for whatever reason, Cloudflare didn't like that page, and so I need to go take a look at that. But this is a great way, as I'm kind of like developing my test on my desktop and working with the interface, that I can make that determination as to whether it's working or not and debug it a little bit. Okay, so we built a test. Now it's time to run it. There's definitely a button at the top of JMeter that you can just run the test from your desktop. The problem you're going to run into is that your desktop only has so much bandwidth. Your kids are watching Netflix on the same network. The machine itself, because the GUI is running, is going to garbage collect more. So you don't tend to get very good results for any kind of scale by running on your own machine. So basically, the workflow is that you use the JMeter GUI to develop the test, and then when you're ready to run it at scale, you do it somewhere else, and you at least do it from the command line. Ideally, what you want to do is run the test as close to the target system. That's intentionally a little vague. I mean, if you're just seeing, can my server handle it? Great, put it in your server farm right next to the same server. Now you're not worrying about the network or any of that. Maybe you're wondering, is my load balancer going to be able to handle it? Great, put the test gear in front of the load balancer, or put it in the same cloud. Whatever you consider the scope of what do I want to make sure is able to handle this load, just get as close as you can as that, so that you're not testing like your house's network connection or the backbone of the particular internet in your area. Ideally, you want to use a dedicated resource like a cloud instance is the most ideal thing, or something like a BlazeMeter instance. And you also want to work with your vendors. The good folks in Umbraco Cloud work very hard to keep your website up and running. And if you just start throwing load tests at them one afternoon, they're not going to be very happy with you because and all the other users that use your same database are not going to be very happy with you. So you want to work with your vendors to schedule this, make sure they know what's going on so that they don't just lock you out of the network and then come yell at you. You also want to make sure you use enough resource, because we're not trying to test the sending machine, we're trying to test the target machine. So if we try to have a single machine send too much traffic, our bottleneck may be in the IP stack of that machine. I think I said 100 threads here. That's for like a really small VM instance. If you run 2 or 3 or 10x scale VMs, you can get much more than that. But you want to just keep an eye on the resources of the machines that are running the test and make sure they're keeping up. Also, when you are doing something at a scale, if I'm going to test 1,000, 2,000, 5,000 users, you are using up a lot of RAM, and all of the things that you're asking it to record use up a lot of disk. So you want to make sure that you're only testing the things that you need to test. So usually, like, you disable the assertions, you disable listeners that aren't needed for your big scale tests. And if you also want to see, like, oh wait, I do want to know some of those assertions, while your big test is running, run the test from your desktop with 1 or 2 threads and look at those assertions so that you're not killing your test by running out of memory. Now, because there's a limit to how much you can do with one machine, JMeter includes a tool called JMeter Server. It's just a different mode that the script runs in. So our typical arrangement is we have a machine that's kind of command and control. And then we tend to fire up a grid of test machines from 1 to 10 to 50, whatever we need, in AWS, and then point those at our target machine. And the test machines and the worker are going to talk over Java RMI. So we already kind of have a pre-configured worker that just has all of the right ports open in the AWS security groups to get around that. But the main thing that we have here is all the machines in the same, this is a self-referential security group, so they can all talk to each other on all the ports within their own security group, because Java RMI is sadly not very port friendly. So we have all that, and then we're going to run the test. For JMeter, the command line is well documented, but basically we're saying we don't want to use a GUI. We're going to use our remote sending grid feed it a test. We're going to have it spit out a listener data file. So what this is basically a file with all the results and calculations in it so that you can bring that file back down to your local machine, load it into any of those listeners to see the data in aggregate, or if you want to do different graphing on it, you have that. And the last two command line variables tell it to generate an HTML report and put that in a folder, because that's also just a really convenient way to look at this. So we kick this off. And because watching a test that runs for 15 minutes is boring, I've sped this up a lot. But this is just a simple test on one machine. I think we only went to about 100 active threads, mostly because I didn't want to cause anybody any problems. And I did break some of those rules that I just told you because this was just for sampling. But we've run this on the machine. We've checked that the machine is running well. And so we get our results. So now that we have results, we want to look at, number one, did the test work? Was it a good test, or did we hit some kind of roadblock? And then we can look at where were we slow and what should we test next. So JMeter, like I said, spits out an HTML folder that has a fairly nicely formatted little report. And let's go through that a little bit. So the first thing it gives us is pass or fail. So how many of our requests failed, how many passed. If we have a high percentage of failure, then we have to start thinking, okay, well, even this is not something that our machines were able to handle, and so let's go dig into that. In this case, everything looked like it passed, or almost everything, so we're good. And then it also gives us, just off the top here, which files do we have here, and what's our aptX score? So what an aptX score is, it's a synthetic score that goes from 0 to 1. Basically, 1 means that for that score, for that request, 100% of the users would be satisfied with how fast it came back. A 0 means none of them would. So we didn't put a lot of load on this, so this is pretty fast. So like our slowest item has an aptX of 0.895, which means 90% of our users roughly are still pretty happy with how that came back. And as we're looking at this, we can see that most of these were media files. This site is not at all optimized. So really what that's telling us is that some of our slowest things were just, we had a bunch of big images on the website that take a while to come down the pipe. Next, let's look at, did the test do what we wanted? So this is our graph of active threads over time. We can see that based on our little stair step, we did indeed start down here at no threads and then got up to 100 active workers. And worth noting, I didn't put any wait times in there. So these workers are just running as fast as they can over and over and looping that journey. So really, like, this is kind of like a normal, a thread represents a user, but like a user on amphetamine, that they are just really going through the site as quickly as possible. So that lets us generate a higher load, but it doesn't mean that threads is essentially representative of a number of users. Because really, again, what we're going for is how many requests per second can we handle, and then we can relate that back to what was our target. So yeah, I see that my requests built over time. The other thing I want to look at is my connect time over time. So this tells me how long did it take between the system starting to make an HTTP connection and when it actually made the connection. Not when it got data, not when it got the first byte, but how long did it take to connect? And I can see that, okay, right at the start of the test, it took a while, and then it settled into a pretty consistent number. So because this is a demo site, it wasn't under load before I started the test. I probably should have done some warming up. But that first request is basically Umbraco starting up and kind of coming out of sleep. And then I see my connections were pretty consistent after that. So that's somewhat of an indicator that my network probably wasn't bottlenecked, because if I had run out of network bandwidth, I wouldn't be able to connect to the foreign machine in a reasonable time, and that number would start to vary. So it feels like this was a pretty good test. And again, you know, we didn't really push this test very hard. So then taking a look at our aggregate statistics, I can see that for each of my samples, I can take a look at, you know, what was my average score, and how many times did we run that sample? How many times did it fail? So for this top one on the home page, on my cat journey, got it in about a quarter of a second every time. But people tend to want to look at the min and max. Max doesn't tend to be terribly useful because what you'll find a lot of times, like if you've ever worked with a browser and sometimes it just doesn't load the page, well, if you do that 6,000 times, requests tend to get hung up. So what you tend to want to look at are these percentile scores. So what these mean is, so if my 95th percentile was at 529 milliseconds, that means 95% of the time I went for that page, I got it in under half a second. So pick one of those, the 95th or 99th typically, and say, okay, I'm going to use that as my metric rather than just the max to get rid of some outliers, and it kind of makes it more relevant. So on an aggregate test like this, some of these other graphs get messy, but I can see that, look at response times over time. So as the test ran, the bottom of that test there is just clock time. So I ran this at about 10 in the morning, I guess. Or no, those are hours and minutes. So I ran it about 2 in the afternoon, sorry, time zones. I can see that some of these stayed pretty consistent. Those are probably my static assets, but some of these, as the number of threads went up, because again, my test is linear, those times went up. And I can also look at the separate graph that is just threads over time, which is a pretty similar graph in this case, but if you run a test where you're like, I want to test at different stair-step levels, this breaks it down to this concurrency equals this response time. And so I can go through this and see, okay, which one of these things are rising? In this example, I've highlighted the news page. So I know in Umbraco, that page pulls a little more content because I'm pulling the content for the news page, and then I'm reaching in and pulling the content for all my articles. So seems like a place where I'm maybe doing a little more than an average page. So what we can do is say, okay, we're going to run this again and just look at that. You can make a new test plan for that, but you can also go in and toggle on and off different parts of the test. And so a lot of times for something like this, okay, we found something slow, let's go in and toggle everything else off and just look at that. And so that's what it looks like for times versus threads for this. And I can see that, okay, over time, that request slows down as it gets more and more load, probably because it's doing more calculation, the server's busier working those threads, and it's taking more database time. And so what do we do about that? Well, let's also take a look at how the metrics are looking. So if I look at my Azure metrics or application insights, if you're using Sentry, you can start to use some of your other synthetic metrics and some of your other built-in metrics to try to detail out what might be going on. Particularly in Azure, you can look at the smart detection, you can look at the dependent failures and see where that might be getting hung up. And then you need to figure out how to make this faster. So these are kind of arranged in an order from least to most work. So obviously, if I want to make it faster, I can just throw more hardware at it. Particularly with a VM, I might be able to buy a 2x, 4x, 8x, 16x machine to run that on. Don't have to change anything, just have to restart it. Obviously, it costs a lot, but if this is a temporary event, that might be a perfectly fine solution. A lot of times, if we're using a CMS, we're using something that's designed for internet scale, it will load balance. So I can also instead say I'm going to scale out. And maybe if I know I have a big event coming up, I can start a larger set of minimum servers. So my minimum server is usually 1. I can start 3 or 5. So I'm ready for the load. I can allow it to max out to go to 30, 40 servers and cover more ground. Beyond that, how can I prevent some of these requests from getting to the server itself? I can use Cloudflare or another, edge buffer like AWS or Microsoft. They all have essentially the front proxies that will allow me to do this. I can also do like donut hole caching, because the problem is if I push some of those requests to the edge and let them cache, maybe there's things on the page that can't be cached. So, example, like if you have an e-commerce site, I probably have something in the corner with a shopping cart and my login. The rest of the page is the same. but this piece is going to need to change. So I can swap that out to say, okay, well, I'm going to use an AJAX call, or I can use edge side includes and have the Cloudflare edge assemble those together. And so most of the page is static. Most people see the same things, but those things I'm personalizing, I can essentially put in asynchronously. And that becomes a lot of, the next level up is what are the things we can do asynchronously or queuing? What can we do to just make the code faster? And now we're getting into a little more work, right? But obviously there are a lot of different levels of caching available even on the web server. I've got hybrid caching on Umbraco, I've got content caching, I've got front caching even with an IIS. I can move some of my stuff out of the request queue. So the big thing we want to do is say, okay, the server needs to handle this request, send the result, and hang up so it can handle another request. So if I'm doing a lot of calculation in the request thread that I can maybe move out somewhere else, that's a good thing to do. Some of that might involve queuing. So if I can't do it fast enough, maybe I have to do it like Subway, where I'm going to take your ticket. And Subway doesn't do that. McDonald's or somebody does that, right? It's like I put my order in, I take my ticket, and then they'll call me back when my order's ready. And so I can use things like MSMQ or other queuing services to essentially say, come back in a minute, and then poll a much faster endpoint to wait and see if my result is back. And so even though the browser's making more requests, it's making them so fast, we're still more performant. Also, I can look at off-server compute. So if my threads are doing a lot of work, can they be doing them in Azure Functions or something? Now I can use a smaller VM because those things are happening somewhere else and still getting done. Beyond that, we can look at how much of this site, essentially, and this is what headless is, how much of this site can we move out to a delivery layer or move out to the edge? So let's serve as much static as we possibly can, and then let's only handle the requests where we have to make a decision or process data back on the server. So, real brief, that's A to Z on JMeter and load testing. More than happy to answer questions. Stick around. I'm sticking around today talking about it. The QR code there both has these slides as well as contact info. Happy to stay in touch on LinkedIn or talk this evening. But thanks for coming and have a good Codegarden.